All right, last time we looked at the FASTA file. Now I'm going to show you where you can go and get some FASTA files. Uh, I'm going to go to Google here. This is actually, even though it looks a little odd, it is an actual Google search page. So I'm going to type in NCBI. NCBI is the National Center for Bioinformatics or biological information. I've forgotten, actually. It's been a long time. And as you can see, I search for this quite often. It actually came up here. I'm going to search for NCBI nucleotide, and we'll go find out where they send us. And I've, of course, been here before. And let's see what it actually stands for. NCBI, let's see here. The National Center for Biotechnology Information. All right, there we go. So going back here this way, I'm just going to search because I specifically want to go to the database that includes nucleotides. Those essentially are the AGCTs, the things that we saw in our first video, those FASTA files. That's what we're searching for. So I want to make sure that I'm under nucleotide. If I were searching for something else, I would choose something else. In a second, we'll probably go look at genome and maybe gene, but right now we want to go search for nucleotides. We want to search and essentially obtain those FASTA files for the things we're looking for. So let's say I type in something, let me see, something interesting here. Let's type in coronavirus and see what we get. That usually gets people's interest. And here we go. It gives us all kinds of sequences here in this format, and this will be useful to us here. And you'll notice it says FASTA. So if this were something we were actually looking for, we would click on FASTA here. Up here at the top, this is giving us the reference genome for coronavirus. So here we go. We get this file. The first file is something called a GenBank file, and it's more information than we need. We don't need all of that information at this point. We're just looking for a FASTA file, and if you look over here to the left, here it says FASTA. So I'm going to click on the FASTA, and here we go. Notice the greater than sign. This is like an ID number for this particular sequence. If you're putting it in a database or you want to classify it and you want to find it quickly. There's the reference sequence number. And then here it tells us what it is. The severe acute respiratory syndrome coronavirus 2 isolate Wuhan Hu1 complete genome. Now, there are some issues with this being a FASTA file. Of course, we don't want all of this up here, and this is a website. You could just grab this like this and cut and paste into a file like we did last time into a text editor. There is a problem. This complete genome probably should be up here in the end. We really don't want this extra line here. If you were to cut and paste this into a file, there are programs that would see complete genome, this piece right here, as part of the sequence, and you're good in error because one, it's not capital, and you've got letters that are not A, G, C, or T. So this is not a perfect situation for cutting and pasting this sequence. Instead, a better way to get our FASTA, at least once we're here, is to go over here and go to Send To. And you go Send To, and what we want to get a file. We want to save it as a FASTA. There are some other things you can get here. You can click on this if you want. It gives an additional ID number. And then you want to create file. So it's going to ask you to open it or save it, and this will happen in Windows as well. And I'm going to open it in a text editor. This is my default text editor. Now realize yours is going to be maybe Windows or WordPad or something like that. And that program, if you save it through that program, it may alter it. Try to use it, try to open it with Notepad so that you drop down here, and if you don't have Notepad here, use Other to find Notepad and open it so you can save this on your file. Otherwise, just save it and then go back and open it as Notepad, but you're going to have to know where it saves it. If you don't know where it saves it, you're going to have to open it. So I'm going to open it with text editor because I know text editor will open it just fine. You need to find Notepad, or if you're using Notepad++, find that one. Do not risk opening it with Word. Word will almost always alter it in some way. So I'm going to open this, and here we go. So notice it is nice and pretty. It's pretty reasonable. I think this is probably 80 characters here. Let's see if I can see that. 71, so 70. All right, so it's saving it as 70 characters across. It's all in, notice it did put it all in one line. That's nice. All right, and I'm going to save this. I'm going to file, save as, and let's see. It already gives us our FASTA extension there. So I don't want to call it just sequence. We can call it, COVID-19 genome. All right, and I can go put this wherever I want it. You know, I'll put it on my desktop, I guess. And it's saved. All right, now this is where you go and you get your FASTA files. And this would be how you manipulate them. If you notice this is the previous FASTA that we created with multiple sequences. So this is, of course, interesting in that we can go look at these. Now realize some of these FASTA files might be huge. This is a whole genome, but it's a genome of a virus, which is going to be relatively small, but it can cause your computer to slow down. I'm on a really powerful computer. I have 256 gigs of RAM, and I have 24 processors plus 2 math coprocessor processing cards in this. This thing isn't going to have a problem with this. Your laptop might have a problem just with this little virus genome. So you have to be careful when you try to open some of these because they will literally grind your computer to a halt, if not cause it to crash. This one probably wouldn't, but if I were to do an entire chromosome, it might, you know, basically stop your computer for 20 minutes trying to load this text file, which has, you know, literally millions of letters in it. So keep that in mind if you're trying to use this data. Don't try and download and view the data directly. If you try to view it all, it's going to slow your machine. You just download it, save it. You know you have it. You can usually save it and then run it in your program, and it will read little parts at a time. It won't try to like visually show you the data all at once like I'm doing here. So let's go down here, and for instance, if these were things that we were interested in, now this is the coronavirus spike S1 fusion protein. This is interesting. So this is a protein that actually is thought to be related to making it be viable inside humans. So we could go look at this. I do the FASTA here, and is it going to give us? Here we go. Let's get it here, and a nice small little piece. It's just a part of a protein that people are interested in researching, and I've been taking a look at it myself. So just realize that these things are going to be here, and this is under nucleotides. So if you're looking for AGCT type data format, this is one of the places you can go. You can also go to entire genomes. So I'm going to do that quickly, and let's go to Homo sapiens, humans. Actually, let's try human, because you guys are probably not biologists. Of course, what does it do? It gives you Homo sapiens. It's kind of smart and tells you what you should do. So here we go. Now here is the interesting thing. We are going to be interested in chromosomes. It's kind of the way the data is. You can now get the entire genome all in one sequence. In fact, you can type in a command and it'll just download it for you. But a lot of times that takes a long time, might take hours to download the whole thing, depending on the speed of your processor, the speed of your internet connection. So usually it's done by most people, but mainly because of the speed of the download, one chromosome at a time. And so I typed in Homo sapiens, I come down here, here is each chromosome. And I can click on this, and here's something called the ref-seq. you should always try to obtain the ref-seq. The ref-seq is the sequence in which all other sequences are referenced from. So this is considered, now whether or not it's legitimately the one that's most common in the population, it doesn't matter. It's usually the first one sequenced, and then everything is referenced off of that. It's not necessarily the best way to do things, but it's the convention to go get the ref-seq, and you compare things in reference to this sequence. So such name, the ref-seq. So you click on the ref-seq here for chromosome 1. There might be other sequences that of this chromosome, other files that are versions of it, but this is the one that is generally used as the reference. And we will go here to File. All right, it's now in GenBank, but we want FASTA, and you would create this file. Now this one is going to be huge. All right, even on my computer, even though I know it can handle it, I'm not going to, because it's going to slow my computer down if I try to open an entire chromosome. Actually, if it were a smaller chromosome, it could do it without a problem. But I know that chromosome 1 is huge, and it might slow it down a bit. So I'm just going to go Save File. I'm going to go OK. And now it's going to be downloading it. So it's downloading. I'm going to see just how big this is. So we've already got 25 meg. I think it's going to be about, if I remember right, about 400 meg. So let's come back to that. It'll be done in a second. A lot of people have talked about finding a better way to organize this data. A text file is not the best way to store data, but that seems to how biologists have done it traditionally, and they don't want to learn any programming to do it in a different way. And they use really old programs, so people are still saving these things as text files. All right, so as that downloads, all right, let's go look at what else we have in here. Of course, you'll have to download each chromosome to get the entire genome. MT stands for mitochondria. You may or may not want to use that. X and Y chromosomes, and here are each of your chromosomes listed. We could go to other species. Let's try a different species here. Rat. What do we get? Do we get rat? It didn't give us any. There we go. Rattus. It's the Norwegian rat, I assume here. Rattus. Might be. I am no specialist on these names, but let's say the Norway rat. Yep. So let's grab this. Let's click here. All right. Here are your chromosomes. You just have to scroll down, click here, and download them. Let's try something else. If we were going to do, let's do cow. See how smart it is if it can tell us the technical name for cow. Bos taurus. There we go. And here are your chromosomes for downloading. So this is how you would obtain various genomes for our analysis. Realize that these chromosomes are large. There are ways to download the entire genome all at once, but I'm not going to show you that here. That requires some command line work. And this is still downloading. We're at 115, 16 here. So we're not going to finish this in time. I believe it's about, I really don't remember. I don't think it's any more than 400. I don't think it's actually 400, maybe 250, something like that. But this is basically how you obtain your data. You would go here and download the sequences in this format.